Hi everyone, and welcome to our last video lesson on 1.6. We're talking about polygons today. Let's first define what a polygon is. A polygon is a closed figure with segments as sides. So we're just going to take a look here at some examples and some non-examples. So I'll circle the examples. This rectangle, this is a polygon. It has segments as sides and it's closed. This one, a five-sided figure, is called a pentagon. All of these ones have straight figures, which are lines that don't have any openings. They're closed figures. This one is closed, and this one. So all of those circled ones are polygons. When you have a rounded figure, like this circle is rounded, that is not a polygon. Same thing with like this, I don't know if it's like a quote type bubble type thing. That one is not a polygon. If this shape right here were to be closed, then it would be a polygon. But it is open right there, so this one also not a polygon. Okay, so a polygon is a closed figure with segments as sides. So let's quickly talk about, I'm sure you guys have all of these, or if not all of these, most of these memorized. You probably knew many of these at a very young age. A three-sided figure is called a triangle. A four-sided figure, many people call these rectangles or squares or whatever, which are all types of four-sided figures, but the broad term is they're called quadrilaterals. Five-sided figures, those polygons are called pentagons. A hexagon is a six-sided figure. A seven-sided figure is called a heptagon, or a seven-sided polygon is a heptagon. Eight sides is our octagon. A nine-sided figure is called a nonagon. Maybe that one's a little bit less known. Nonagon is a nine-sided figure. A decade has 10 years. A decagon has 10 sides. And then do means 2, deca means 10, so a dodecagon is a 12-sided figure. These are the names for those polygons. Any other polygon, any other like a 11 sides or a 23 sides or a 65 sides, anything else besides these that I have on the board, we just call them n-gons. So again, if a polygon has 16 sides, we would call it a 16agon, or a 16gon rather. Okay, so any other ones that are not written on here, we just call them the number of sides that they have, and then gon at the end. 23 sides is a 23gon. So on and so forth. We're going to be talking about concave and convex. These are more science-related terms, especially when dealing with like reflecting lights and stuff like that. A concave lens causes light rays to spread apart. So if light goes in here as it comes out, it causes the light to spread apart. The exact opposite with a convex lens. As light comes into a convex lens, it causes it to merge. So if all this light is coming in here, it's causing it to merge into one beam. So kind of some science terms. Concave mirrors, convex mirrors. You maybe see these at like a arcade type place or a play place type of thing, where it can kind of distort your image to make you look taller or shorter or wider or skinnier than you are. There's a lot of cameras and stuff like that where you can take selfies and make your face look kind of more scrunched together or more spread out. Those are concave and convex mirrors. The reason why we talk about that is because we talk about concave polygons, and here's what a concave polygon is, or some examples of concave polygons. It's where there is at least one vertex pointed in. So a cave is almost kind of like a place where you get some shelter. Like this vertex right here, it kind of has like a little inlet right there. The vertex is pointed in towards the shape. This forms a little cave right here. There is one vertex that's pointed in towards the shape. Here, this star, or it's actually properly called a decagon, it has 10 sides. All 5 of those vertices are pointed in towards the shape. And same thing with this arrow right here, which is a 1, 2, 3, 4, 5, 6, 7. This heptagon is a concave heptagon because two of the vertices are pointed in. One way I kind of like to describe this, if you were to continue some of these segments, so if I were to continue this line, it would go right through the middle of my shape. Same thing here, it would go to the interior if I kept on going with this. On all of these, if you ever continue these segments, a concave one is where if those segments were to continue, it would go through the interior of the shape. Whereas convex polygons, exact opposite, convex polygons are where all vertices, so the plural of vertex, all the vertexes, all the vertices are pointed out. So here on this quadrilateral, all four of these are pointed out. If you were to continue any of these line segments, they would not go through the interior of the shape. They would always stay on the exterior of the shape. All five of these vertices on the pentagon, all of them are pointed out. You could continue these line segments and they would not go through the middle of the shape. Same thing here on this hexagon, all the vertices are pointed out, so those are convex, and this triangle, all vertices are pointed out. So that's the difference between a concave and a convex polygon. And then a regular polygon. This is a big term that we use a lot in geometry. A regular polygon, those are special polygons where all the sides are the same length and all the angles are the same measure. So all sides are congruent and all angles are congruent. So here on this pentagon, if this side right here is 7 inches long, then this side is 7 inches, this side is 7 inches, this side is 7 inches, and this side is 7 inches. Okay? And all of the angles are also the exact same measure. If one of them is 120 degrees, they're all 120 degrees. If one of them is 140 degrees, then they're all 140 degrees. On the quadrilateral, a special type of quadrilateral, the regular polygon quadrilateral is called a square. All four sides are congruent, all four angles are congruent, and all four angles are 90 degrees. On the hexagon, once again, if it's a regular hexagon, all 6 sides are equal length, all 6 angles are equal measure. And with this triangle, the way we would mark it up, all of these sides are congruent, so we'd call it an equilateral triangle, and all the angles are congruent. They would all be 60 degrees, so it's equiangular. So an equilateral equiangular is also called a regular polygon. But it could be any shape, an octagon. If it's a regular octagon, all of the sides, all 8 sides are congruent, all 8 angles are congruent. It could be a regular decagon. All 10 sides are congruent, all 10 angles are congruent. A regular polygon just means all sides are congruent and all angles are congruent. All right, let's do one problem here. Kind of deals with a word problem involving with perimeter. The length of a rectangular garage is 6 times its width. Find the length and the width of the garage if the perimeter of the garage is 280 feet. So a rectangular garage would be like, here's my garage kind of a thing. And it says that the length of the garage is 6 times its width. So if here's the length and here's the width, this length is means equals 6 multiplied, or 6 times its width. So I might write that in this English sentence that I'm underlining in red. In a math sentence, the length, L, is means equals 6 multiplied by its width. So now this rectangular garage, instead of length, width, I know that the length equals 6W. I wrote that right here. So instead of L, I'm going to put 6W and 6W. Now I have one variable, W, I can solve for that. So the perimeter is 280 feet, and the perimeter means all four sides are added together, or perimeter means all the sides of the polygon added up together. So I'm going to have 6W plus 6W plus 1W. All four of these sides I'm adding together, and I'm going to set it equal to the perimeter, and the perimeter is 280 feet. Now let's solve. 6, 7 plus 6 is 13 plus 1 more. There is 14 W's. 14W equals 280. And then to solve for the width, I simply divide by 14. So 280 divided by 14, the width is 20. And our units, we're talking feet, aren't we? Yes. So the width is 20 feet. So going back to my instructions, it says find the length and find the width. So if the width is 20, the length is 6 times the width. So it would be 6 times 20. So the length is 120 feet. And that is the correct answer for this question. Let me know if you have any questions on that or any questions on polygons when you get to class tomorrow.